So again, on problem 2, I would like to see where is the slope of the tangent 0 first, so I'll know my turning around points, and then I'll look to the left of those spots. So of course the first thing I have to do is take the derivative, pause and see if you can simplify it yourself. So I'm running out of room. Take a look at what I did. I took the derivative first, and then I distributed. That's how I got these first two pieces. Then I took a negative sine x out of everything. And then I switched the cosine squared into 1 minus sine squared, since everything looks, especially on the bottom, like it's going to be in sine, and it's easier to work with if it's all one trig function. So I'm going to erase this and put the next step. Okay, so I combined like terms in those parentheses, and I got 3 minus sine squared. So now I have to remember, I'm still after the turnaround points, so I want to set it equal to 0, but since it's a fraction, that's essentially like making just the top equal 0. I could mathematically multiply both sides by the denominator and make it magically disappear on this side. And if I do times 0 on the other side, it's still 0. So now I have zero product property, which means either this factor is 0, so I'll set it equal to 0, or this factor is 0, so I'll set it equal to 0, and then I'll solve. So pause the video and see if you can solve these. So here are my choices, but I have to look back up at the interval, and I noticed that the interval's open on 0 and 2 pi, so I can't include these because they're not included in that interval. And then square root of 3 plus or minus square root of 3, that's greater than 1 and less than negative 1. And remember, my sine value doesn't get past 1 and negative 1. If you need to convince yourself, you can look at the graph of sine and remember it goes up to 1 and down to negative 1. So those answers are definitely out. So the only turnaround point I have on this interval is at pi. So now when I test my interval, I want to go from 0 to pi and from pi to 2 pi. So pi will be the turnaround point, and now I want to know what's happening to the left, so I'll have to pick a number. How about pi over 2? So f prime of pi over 2. And in this second interval over here, let's do f prime of 3 pi over 2. That'll be easiest. Oh, and I almost forgot all this over here. I hope someone made some note of it. So remember, turnaround points don't just happen where the slope is 0. They also happen when the slope is undefined. So I set it equal to undefined, which meant the denominator needed to be 0. And when I solve, I'll get a squared value equaling a negative, which is no solution. So yay, I didn't introduce any new turnaround points. So now I just have to decide what's the slope at pi over 2, what's the slope at 3 pi over 2. So I'm going to plug them into the slope formula to figure that out. And when I plug those numbers in, for pi over 2 I get a negative number, so I really only care about the sign, but I showed you how much it was. And for 3 pi over 2 I get a positive number. Again, I actually got positive a half, but I don't need to know exact number. So on the first piece, since the slope is negative, this one here is decreasing at that moment prior to pi, and then after pi it's increasing. And on this next one, since I'm looking at the graph of f prime, I'm looking at the graph of slopes, so I look at where it is with respect to the x-axis. So up here the slope is positive because it's above, then my slope is negative because it's below, then my slope is positive because it's above, and then negative because it's below. And so I know it's increasing, and then decreasing, and then increasing, and then decreasing. And I can see where, because 0 to 2, and then 2 to 4, and then 4 to 6, and then 6 to infinity. And I could separate them to make it more understandable.